how does nuclear energy actually work? And what role does that glowing green liquid in barrels play in your everyday life? How does it make your morning coffee possible, let you listen to your music, or even watch this video right now? It's a fascinating process that connects cutting-edge science to the things you and me enjoy the most. Let me walk you through it here, how the nuclear energy keeps your world running smoothly, and does that every day. Now, I know what's on your mind. Chernobyl and Fukushima, and you're probably right. Those names carry shadows of accidents that shook the world. But let's step into the story and see what's really happened and why today's nuclear landscape tells a very different tale. Picture Chernobyl, 1986. It's a cold night in Ukraine and a reactor sits exposed. No containment dome to shield it, and all design begging for trouble. Add in a dose of human errors and it's a recipe for chaos. The result? A disaster that became a warning and engraved in history. Fast forward to Fukushima, 2011. An aging plant built with yesterday's tech stands on Japan's coast. Tsunami slams in, knocking out backup systems that just couldn't keep up. Another chapter of struggle unfolds. Yes, accidents happen, but here's the thing. Modern reactors are nothing like those old designs. What if modern reactor overheats? It just stops. No explosion, no radiation leaks. It's like your iPhone overheating. It just shuts off. That's why even governments and companies that were skeptical about nuclear energy before are now getting on board. This is the story of progress rising from the ashes. Stick with me and I'll show you how. So how did nuclear energy first come into being? Let's rewind to its birth, a spark of discovery that lit up a new era. And then, leaping ahead, what's being done right now to log those catastrophic chapters in the history books for good. Join me as we unfold how this power took root and where it's steering us next, and affordable. So how was nuclear energy invented? The story of nuclear energy begins in the early 20th century with scientists like Albert Einstein and Enrico Fermi. Einstein's famous E equals mc squared basically told us that the mass can be converted into the energy. Then in 1938, German scientists Otto Hahn and Fritz Strassmann accidentally discovered nuclear fission, splitting atoms to release energy. Not long after, the Manhattan Project turned nuclear invention into something, well, destructive. But after World War II, scientists realized, hey, instead of making bombs, why not use this insane energy potential to power cities? And in 1951, the first ever nuclear-generated electricity was produced in Idaho. By the 1960s, full-scale nuclear power plants were being built over the world, until came the game changers. Chernobyl in 1986 and Fukushima in 2011. But who really pushed nuclear off the stage? Well, ordinary people, rattled by these disasters, marched with the science and demanded change. Anti-nuclear movements grew loud, especially in Europe. Germany's Green Party, for one, turned that fear into street policy, leading a phase-out of nuclear power by 2022. Other governments followed as well. But it wasn't just the people. Environmental groups like Greenpeace threw their weight behind the cause, painting nuclear as a radioactive boogeyman next to the cleaner promise of wind and solar energies. Politicians also leaned into renewable, cutting down nuclear funding. In the US, cheap natural gas stole the spotlight. Why? But on a costly reactor when gas was quick and affordable. Big energy firms, won nuclear's champions, turned their backs too, chasing profits over long-term vision. Even international bodies like the International Energy Agency noted nuclear's decline in advanced economies. The past has laid it all out for us. History is clear. We've got that locked down. But before we charge ahead, let's circle back to the nuclear ABC and refresh ourselves on how this powerhouse actually works. Step with me for a moment as we revisit the essentials of nuclear energy and set the stage for what's unfolding now. So, how does nuclear energy work? Inside a nuclear reactor, we have fuel rods made of uranium. This uranium atom gets hit by neutrons, causing them to split in a process called fission. The splitting releases heat, which turns water into the steam. The steam spins the turbine, which generates electricity. That's it. The process is actually similar to a coal plant, except instead of burning coal, we're using physics to unleash atomic power. Imagine an atom as a tiny glow stick. Crack it, and it lights up. That's efficient. Here's the deal. Nuclear energy uses uranium, a heavy metal dug from the earth. Inside the reactor, we fire a neutron, like a cosmic ping-pong ball at the uranium-235 atom. It splits into two small atoms, releasing energy and more neutrons, which hit other atoms, and it's a chain reaction. That energy heats water into steam, spins a turbine, and powers our cities. Simple, right? Well, not that simple. There is a billion safety valves and cooling systems to keep it from turning into a Hollywood meltdown. Now, the waste. Those split atoms are radioactive leftovers. They're handled like hazardous trash, sealed up, and burned deep. It's a small price for the massive energy output. One uranium pellet, the size of a gummy bear, equals a ton of coal. Coal, that means pollution, CO2, ash, and lung diseases. Nuclear, no CO2, no air pollution, and enough energy to power millions of homes with just a few fuel rods. Safety of nuclear today means no more meltdown mayhem. Fast forward to today, what's being done to keep those dark days of Chernobyl and Fukushima behind us? The tide's shifting again. Modern reactors, like small modular designs, are built tougher. Think automatic shutdowns, steel-clad containments. We enter the era of small modular reactors, SMRs, and modern power plants. SMRs are like the Tesla of nuclear, compact, efficient, and packed with safety goodies and technologies. They're built in factories, not on site, so they're less prone to technical errors. Plus, they got passive safety systems. If something goes wrong, they shut down automatically, no human involvement needed. It's like your smoke alarm turning off the stove before the kitchen gets on fire. Medium reactors and big plants are leveling up too. New designs use molten salt or sodium instead of water, harder to mess up. And the statistics? Nuclear is one of the safest energy sources per gigawatt. Way fewer deaths than coal or oil. Governments of over 20 countries from France to China pledged to triple capacity of nuclear energy sources by 2050 at COP28. Engineers are refining safety, learning from every misstep. Nuclear isn't that. It was just caught in a perfect storm of fear, finance, and fossil fuel competition. Let's sum it up. Nuclear energy began with pioneering minds unlocking the secrets of the atom, harnessing the potential through the fission of uranium to drive turbines and generate power for us. Today, advancements in small and medium reactors have elevated safely to the highest level, distancing us from the risk of past incidents. From the humble beginnings of Chicago Pile 1 to the innovative nuclear power container ship unveiled by Hyundai Korea Shipbuilding and Offshore Engineering in 2025, the technology has traveled a remarkable path. Challenges like waste management and initial costs persist, of course, yet the field is advancing rapidly, refining solutions with each step. It stands as a clean, potent force, one that could play a major role in shielding our planet from environmental collapse. The next time you turn on a light, consider the atom's quiet contribution to that moment. So, where do you stand? Are you convinced by nuclear's potential or no? Share your thoughts in the comments, hit the like button if this resonated to you, and subscribe to join us for more exploration of science and nuclear innovations. Until our next chapter, keep questioning, keep learning, and let's look to a future of power wisely.